All right, so now we're going to do example 4, and I wrote the formula up here again for partial derivatives. And again, we usually, if the literal rate does not work from the beginning, like we used up here, let u be natural log and arc sine or inverse sine, we usually let dv be the most complicated part. So u in this case is what we're going to let x squared be because it's least complicated. And dv is going to be sine x, which means if I integrate dv, I get v, and the integral of sine is going to be negative cosine x. And then over here, the derivative of u is going to be 2x dx. So we're going to stick this thing into this formula. Again, this is integral u dv, okay, u dv. And so we plug this in over to this part. So this is going to equal uv, which is going to be x squared times negative cosine. So I'm going to take negative times x squared. It's negative x squared cosine x. And it's going to be minus the integral of b, which is also negative cosine x. We're going to take that negative out front with this negative to make a positive cosine x. And we got the du. So we're going to stick the 2x in front of that cosine x. And then we're going to stick the rest of the du, the dx, out here at the end. Okay, so now we still have like a product rule here, just like this. So what that means is this happens sometimes is that we got to go back and do this whole thing again using this part. So now I'm going to let the u, I'm going to use a different color here. I'm going to let the u equal the variable part again. And then I'm going to let the dv be the more complicated part, the cosine x dx. So du is going to equal 2 dx. And then the dv part, the v, doing the integral of dv is v, doing the integral of cosine is sine x. So now I'm going to do this whole thing again with this part. Well, I keep the part in the beginning the same because it's done. So this is negative x squared cosine x. And then we got plus, and now we're going to do the uv part again. And it's a plus because that's a plus. So the uv part are these two things. So this is going to be 2x sine x. And then minus the b du. Well, b is sine x again. So it's going to be the integral of sine x. And then the du part is this 2 dx. And we're going to stick that 2 out here in the front. We're going to take this 2 out to the front from that dx. And then, so these two parts are finished. So I still got negative x squared cosine x, and then I got plus 2x sine x. And the minus 2 and the integral of sine is going to be negative cosine. So instead of doing the negative with the cosine, I'm going to stick it out there with that negative and make that plus. And then we get a plus c, and then this right here, that whole long answer right there, that is going to be our integral of this problem. So sometimes you got to keep doing this over and over again until you get finished. So I've had to do it as many as 4 times before, so there's no guarantee that just twice is going to get you there. So you just keep going until you basically, like if you have a cube here or a 4th power, you're going to have to keep doing it a lot of times, whatever this biggest power is, until you get it down to just this du part just becomes a constant. So that's a repeated using of the integration by parts.